What we need to find out here is Vy, the voltage across the current dependent current source. The current dependent current source has a value of 29 IB. The control current IB is this one. So first we will try to find out IB. So what I will do, I will try applying KVL in this loop, this one in clockwise direction like that. So I'm erasing that thing, and I have to also, I should be careful in this particular circuit about the units of the resistances. So this one is a kilo ohms, while these two are in ohms. So I will probably convert everything into kilo ohms. So this one will become 200 ohms will become 0.2 kilo ohms, and 500 ohms will become 0.5 kilo ohms, and that way the current that we will get if we convert the resistances into kilo ohms and the voltages, if they stay as voltages, the current will become in milliamps, because milliamps times kilo ohms is voltage, volt. So anyway, I am applying KVL in this loop, in this direction, in the clockwise direction. So I will write the rises as negative and drops as positive. So this one is a rise, this one, the direction of current is in this direction, so this will be like that, and then this one, and the current through the 200 ohms resistance or 0.2 kilo ohms resistance is the addition of this current and this current, because we apply KCL here, and IB in this direction, 29 IB in this direction, so the current will be downwards, that will be 30 IB. So I'm just writing that, and I am also writing the sign, so that will be a drop. So now when I write the equation KVL for this loop, starting from here, 15.2 is a rise because going from minus to plus, so that's a negative 15.2. Then I have this one, the voltage drop across the 10 kilo ohms resistance, so that will be a drop, so plus 10, because plus to minus, that's a drop, 10 IB. Then minus to plus again, this 0.8 volts, so that will be a drop. And finally this one is also a drop, 0.2 times 30 IB, so that will be a drop, plus 0.2 times 30, 30 IB there is equal to 0. So basically 0.2 times 30 is 15, so we have 0.2 times 30 will be 6 IB, so I am writing it here again, minus 15.2 minus 0.8 is becoming minus 16, and this is plus 10 IB, and this one is 30 times 0.2 is 6, so plus 6 IB, that's is equal to 0. So if I take, so it becomes 16 IB here on the right hand side, 16, so I am getting IB as 1, and the unit will be milliamps, because I have considered the kilo ohms resistances. The unit was unit of the resistances were kilo ohms, so that's there. Now I have IB, so what I will do now, I will apply KVL across the outer loop. So this one, the big one here in this direction, again in the clockwise direction, so I'm just erasing that part. So starting from here again, 15.2 is, I will again write the rises as a negative, so 15.2 is a rise, 0.2 there, and then 10 times 1, that's a drop, 10 kilo ohms, so that's 10 just because the current is 1, so 10 kilo ohms times IB, that's 10, and then the rise again 0.8. These are the old ones because it's the same, still in the same part. Up to here it was like that loop. Now I will go here, this is minus and plus Vy, and that is what we need to find out, and this is, since we are going in this direction, in the clockwise direction, Vy is a rise, so that will be a negative. And then I have 500. Now I have to remember I didn't put any sign, the drop sign across this resistance, so that will be plus here, minus here, because the current is going in this direction, so plus here, minus here, and when we are going in this direction, that will be a rise, because we first from rise to from minus to plus we are going, so that will be a rise, so that will be a negative, and the value will be 0.5 times 1, so basically it will be sorry, it will be 0.5 times the current is actually 30 IB, this branch current. This one is, sorry, 29 IB, this branch current. This one was IB and this is 29 IB, because this branch current is defined by this current controlled current source. So 29 IB is 29 because IB is 1. So 0.5 times 29, I'm just writing like that now for the time being. And then I have this one which comes as a drop because I am going in this direction. So that's plus 25 is equal to 0. So I have minus 15.2 there, plus 10, minus 0.8, minus Vy, and 29 times 0.5 is minus this one, and 29 times 0.5 is 14.5, half of 29 basically, plus 25. So like that. Now if we just rewrite it here, we have 10 and 25. So that's, so what I have done is practically I have taken the Vy on the right hand side so that that gets a positive sign, but I am writing here in the left hand side. So 25 plus 10, the pluses and minuses remain the same in this side, that's 35. And here I have 15.2 minus 0.8, which is 16, and then minus 14.5, so that is minus 30.5, so which is 4.5 volts. I will get in volts because the current was in milliampere and the resistances were in kilo ohms. There were two currents, this one and this one, both in milliamperes. So yeah, it's a bit clumsy, but I hope it's understandable. So this is my desired voltage Vy. The direction is the same as this one, the given one. So since the result is positive, so the voltage drop is in this direction, and the value is Vy, which is 4.5 volts. So what we can see that in this current source there is actually the current direction is in this direction, but the voltage drop in the direction of the current, there is a drop of voltage. So this one is actually dissipating power. In this case we can see, we can observe that phenomena here, and it happens actually because this is by anyway this is a dependent source, and also in sometimes even independent source can dissipate power depending on the connection and everything. We have seen that earlier as well in previous some of the problems. So anyway, that's the result here.